Okay, so let's start doing some examples with confidence intervals. In the last video, we looked at what a confidence interval was, and we were able to establish the formula that we use with confidence intervals. So let's just go back to it and just remind ourselves again the three things that we need to find a confidence interval. We need a sample mean, we need a deviation, a standard deviation, and we need a sample size. So what we're going to do is we're going to be looking at how we use the confidence intervals formula, and it's really important to understand how this works. We can't just forget about it. Even though we've got a calculator we can use to get our answer, we do need to know how this formula works and how the different parts come together for a later question which we'll look at during this video. So we'll also look at how we can find the confidence interval on your calculator and how we can change these z-scores used in your calculator as well. So let's start off with the first example. We've got a sample of 50 mangoes was taken randomly from some recently harvested fruit. The mean weight of the sample was 236 grams. The population standard deviation was 24.5. Find the 95% confidence interval for the population of the mangoes using the formula. So whenever we're working with this kind of data, I like to write down what I know I need. So I know I have a sample mean. So the sample mean here is 236. My deviation is 24.5. And my sample size is 50. So this question is asking us to write the formula out. So let's replace the sample mean, the deviation, and the sample size in this formula. So we would have 236 minus 1.96, remembering 1.96 is the z-score for 95%, 24.5 over the square root of 50 is less than equal to the mean, which is less than equal to, again, 236 this time plus 1.96, 24.5 over the square root of 50. So we've got our lower value here. So if we were going to calculate this manually, this here would give me my lower value. And this here would give me my upper value. And what we are looking for is that we're looking for these two answers. One will be below the mean and one will be above the mean. So if we don't get that kind of calculation, then we've done something incorrect. So we've got our formula written out in terms of the forms of sample mean, standard deviation, and sample. But we can use our graphics calculator to get this answer. So on our graphics calculator, what we use in this instance here is we're going to come straight back to statistics. Alright, click on statistics. This time we want to go into inter. Okay, so we click on F4 for inter, Z, and then one sample. Now you will know you're in the right place if you've got four things. You've got the C level, which is your confidence level, 95%, okay? You have your standard deviation, you have your sample mean, and you have your sample size. If you don't see all those on this screen, then you've done something incorrect. If, however, you go back up here and it looks like this, then have a look at this data first. You always want this to be in variable. So let's now plug in these 3 points, leaving the 95% as your answer, and seeing what happens to the graph. So we've got a deviation of 24.5, 236, and 50. So let's click enter. What we get here is we get, let's go back again, let's just double check. Exit. No, we didn't go down to this, and this didn't work for me. 50. So what we have here is we have 229.21 is less than the mean, which is less than equal to 242.79. Now this here makes sense. I mean, that makes sense for the main reason that our lower bound, or our lower end, is definitely less than 236. Our upper is definitely above the average of 236, so we know we're on the right track here. We could also go back and look at the normal distribution curve, knowing this is 95%. Okay, so 95% is 2 times the deviation, so if I'm bringing it back 2 times the deviation, I could work out what this deviation is and then see if I can subtract it back. But we're not going to be worrying about in this case here because we know that this answer is correct. If we were going to write a statement on this, we would write a statement by stating that we are 95% confident that the weight of the mangoes lie between 229.21 grams and 242.79 grams. That is the statement we'll do that will describe this confidence interval. So let's have a look at what happens when we do some variations. Let's say that we want to change our confidence interval. Let's change that and say, well, your confidence interval, your standard deviation, let's change that to 30. Well, what happens to our graph when we change the standard deviation? So let's go back, go up here and change our standard deviation to 30, and then we'll have a look at the answer. Well, what happens here is, remember, this here was 24.5, okay? It's got a width of about 11, say about 14, so about approximately 13 it has a width, okay? This next one here gave us an answer of 227.68 is less than or equal to the mean, which is less than or equal to 244.32. So this time here, we've increased the width. So it looks like we've got 13, so we're going up to approximately 17 now, when your deviation is 30. Can you see a link what's happening here? We're increasing our deviation, so therefore if we increase our deviation, we're increasing the width of our confidence interval, which makes sense, because remembering, coming back to your distribution curve, here are your deviations. If these increase, that's going to increase your curve even further. If we decrease it, then it comes closer to your mean. But what if, let's take this back to 24.5. What if we change the sample size this time? So let's say the sample size was 70. Remembering that the width in this original one was 13 with a sample size of 50. We're now going to do it to 70. So let's have a look and see what happens. If we exit out and we're going to change this back to 24.5, but we're now going to change our n to 70. Oh. Look what happens here. We get 230.26 is less than or equal to the mean, which is less than or equal to 242.7. So it looks like it's increased slightly, okay? So that makes sense. So let's now change this. Let's change this to, say, 150 this time. Okay, we have 150 samples. So let's go back. Let's have a look at what's happening when we have 150 samples. So 3 times the amount. We see that it decreases. What did we say about central limit theorem? We said as we increase the sample size, your graph decreases and becomes more normal. Well, this is what we're seeing here. At 70, it's reduced slightly, okay? At 150, it's reduced now down to within 7. So it's done what the central limit theorem's told us it's doing. Okay, so when we do increase the sample size, we're going to be making our confidence interval decrease because it's becoming approximately more normal. I did say that we need to remember how this formula works. So this formula makes up a component where we can actually find out the lower and the upper end is. And it's important to remember how this formula works because our next example, which we're going to do in our next video, is how we can reverse our calculations. And I'll see you in that.